Science is like a pyramid. At the bottom, we have the widest base, observations and facts. These are the raw measurements and data collected from the world around us. For example, we might observe that the sun appears to move across the sky over the course of a day. We can measure the length of time that each hour takes and calculate the speed at which the sun appears to travel. And we can even collect data on what time it rises and sets over the course of a year. All of these are just facts and observations about the motion of the sun. They don't really tell us anything about why the sun moves or what causes it to rise and set. That's where hypotheses come in. Scientists build hypotheses from the facts and observations. A hypothesis is a testable idea that tries to explain patterns we see in nature. So, for our example, one possible hypothesis could be that the sun is actually a ball of burning hot gas that is round. We can then design an experiment to test this hypothesis, perhaps by throwing a ball and seeing if it follows a curved path, just like the sun appears to move in the sky. If we find that our hypothesis is supported by evidence from the experiment, then we can move on to the next layer of the pyramid. Next come experiments and models. These are structured ways to test those hypotheses and simulate how systems behave. Experiments gather data, which can either support or refute a hypothesis. If enough experiments support a hypothesis, then it becomes part of a scientific theory, a broad explanation that ties together lots of different facts. For our example, the hypothesis that the sun is a ball of burning hot gas was supported by many experiments. So it became part of a scientific theory called the heliocentric model of the solar system, which explains not only why the sun rises and sets, but also why planets orbit the sun, and why there are seasons on Earth. At the top of the pyramid, we find scientific laws. These are concise, often mathematical descriptions of how nature behaves. For our example, Newton's law of gravity explains why the sun and planets orbit around each other. The heliocentric model is a scientific theory, and Newton's law of gravity is a scientific law. The pyramid shape reminds us that science starts broad with many observations and narrows into universal principles. But it's never fixed. New discoveries at the base can reshape the whole structure above. For example, Einstein's theories of special and general relativity redefined our understanding of gravity and the laws that govern the universe. They are a testament to the power of the scientific method and the human desire to understand the world around us.